Hello, Chapter 17, Software Reusability. This is a small chapter, it's just pretty much a review chapter, so it shouldn't be that long, about maybe 20-25 minutes. So we are going to talk about why is reuse difficult and how to realize reuse. I remember many years ago in industry, reuse was really the key buzzword. So a lot of benefits to reuse. Most important thing is you don't have to waste so much time. Other people have already done it. And what can you reuse? What are the backward, forward compatibility, etc. So we're just going to do a brief overview of the software reuse. First of all, what are the dimensions for reuse? Okay, what can I reuse? Often people just focus on code, but it could be much more than just code. It could be things such as component, concept, UML, documentation, diagram, requirements, test plans even. So reuse is anything that has potential. But often, as I said, most people, when they think reuse, they think reuse in the context of code reuse, which is probably the dominant one. Okay. What is the scope? It could be horizontal or vertical. We're going to talk about this one. And the approach is systematic or opportunistic. So these two is the main concept. We also want to talk about what technique. Is it more compositional or is it more generative? So we're going to talk about this. And also, is it black box or white box? Okay, and remember the concept of black box means you don't know the internal of it. You don't have this lines of code. You just know it as a package. Or white box, you actually have every single line of code. So, for example, somebody may give you a search. Okay, you don't have the binary, but you know what it does. So you reuse it. You just put the binary in there as executable. But sometimes they give you the source code for the search. So that's the difference between black box and white box. And product being reused is this, as I said, source code, design plan, etc. Okay, what are the success criteria for good component libraries? Okay, and remember, it has to be well-developed field and a standard terminology, small interfaces, a standardized data format, because other people are going to reuse it. Like, for example, you write a search routine or login routine or a payment routine. It has to be compact enough so other people, when they want to use it, they take it. Okay, but remember, there's a thing. What if you're trying to do sorting? Okay, you use this sort of sort routine, and then you decide to extend that sort definition. Maybe the sort original one that you're reusing is only sorts numerically, gives you numbers, but now you want to do alphanumerically. Okay, you want to have, characters and numbers. So we have to kind of watch out for these little pitfalls. So requirements for component libraries. First of all, searching for components. That's the key thing. When you reuse things, you have to provide a means to search for it. I mean, it's kind of like if I'm trying to reuse somebody else's code, whether it's inside my company or it's an open source, you should be able to search for it, have some keywords, some primary keys, or some names, so you can go ahead and find it. Also, understanding and evaluating the components, because sometimes, let's say you're trying to use a payment method for reuse, but when you search for payment, there might be 8 different components that you could reuse. How do you know which one is the better one? Okay, so we typically have some kind of evaluation. The simplest one is how many people have reused this before, right? So if you say you search for something, a login or a payment, and gives you 3 different payment methods, it's just you want to use that code inside your code. And you say, well, this one has been only used 5 times, and this one has been used 400 times. Of course, the one 400 times, that means probably it is more demanding or probably a better one. It's just like games. Sometimes you download a game and you say, well, it's a chess game, but this has been downloaded 10 million times, but this one has been downloaded only 20 times. So you kind of know the general notion, probably the one used more is better. Also, you want a compose system from components, right? That's the key thing. You never get a piece that's standalone. You always want to put it in something else. So you have a whole system, maybe with payments and logins and searches and whatever the functionality is, but you reuse a piece maybe for the sorting part, you put it in there. So you compose it, right? So first key thing, let's talk about component evaluation. What are some useful information? Okay, i.e., I want to use your component. What should I watch? Is first you need to include quality information. Okay, as I already mentioned, sort of the number of hits, or how popular this is, or how many times this has been viewed. Also, we want to have administrative information. Okay, for example, the name of the developer, modification history, these are very important. And of course, the most important thing is also the documentation. You should be able to see the documentation, and after that, interface. What kind of interface do you need for this search or for this payment, i.e., what do you pass to it? Remember, this is not your code. You got that code, you're reusing it. That means somebody else wrote it and you're just borrowing it or putting it in yours. So you need to know what is the interface, and of course, what is the test information. How is it tested? So reuse process models. We have extremely important slide number 6. We have two models, okay? One is called software development with reuse, okay? And the next one is called software development for reuse, okay? So this with or for is extremely important. With reuse means it's very passive, and component library evolves in a very haphazard manner. That means you accidentally wrote something that's good for things. Let's say you write, maybe a component for a game, okay, or maybe a payment method, but you didn't mean to share it with others. But at the end, you say, "Oh, that's a cool one. Let's share it with others." That's with reuse. That's very passive. But what if before you write that component, you could say, "Oh, I'm gonna make that reusable by others." In other words, you intentionally plan for it. That's why it's called for, because you plan for it, right? So this is very active. That means you actually actively participating in reusing. And reusable assets are developed rather than found by accident, right? Because see, this is found by accident, but this is really you develop it for the purpose of reusing it. So we got two diagrams here. This is software development with reuse. And remember, once again, with reuse means very haphazard, very passive, accidentally you wrote something that is good for reuse. And then I'm gonna show you something for reuse, which is more systematic. Okay, we actually call this one systematic, right? So they're very close to each other. Let's first compare, right? In all of them, you start with some requirements, okay? Let's compare this one with the next one, okay? Slightly different here though, okay? So in this one, you just have some well, let's finish this one, maybe go to the other one. You have some requirements. I talked about it last lecture, requirement engineering. So you have some requirement, you go elicit some more. Okay, now that I have all my requirements, I go to the design phase. Then I'm going to search to see if there are any components that I can reuse. Okay. And then if there are, I'm going to evaluate those components. Right. So, and basically at some point, right. So I'm going to use it. There's a repository, and I'm going to check my part in. And after that, I'm going to go to the, more design, implementation, and testing. That's a typical system that you do. Basically, requirements engineering, then find out, is this component something you want to share it with others, right? And then you design. But now let's say this is sort of in a sort of accidental way. I wrote this thing. Maybe this is payments. Oh, it's cool. Let me share it. So you put it in the repository. But let's say, what if you definitely want to do it? Because this one you may choose not to do, or as I say, it's accidental. Now, for reuse is a little bit. You have to consider the domain, okay? Because remember, when you have a search, you have to also look at what other people you search for, right? Maybe you were just searching for, or maybe you use sorting. Maybe you were sorting by numerics. But what if I want to sort by alphanumeric? What if I want to sort by wild character alpha plus alphanumeric? So here it's called domain analysis. Let's look at all these systems. It doesn't have to be two systems, three, four, as many as you can see. See, how are they actually using the basically this sort or this search or this login, whatever you do? What is the difference? And then you want to get a superset of it. For example, if for your program only you need to write a sort routine that sorts numerics, but then you look at another system and says, oh, they want also alphanumeric. And then another one wants alphanumeric and wild characters. So you might as well write a sort routine that has all of them, even though for your own project you only need the numeric, but you create the whole thing because you're going to look at the whole domain. So now that is one difference between the last one, right? That one you only look at your own project and where your product fits. This one you're going to look at others. Another one is this one, okay? Notice here we only looked at design, then we search for components, and then we sort of evaluate that one. But in here, we go to the design, and then from here we are going to talk about object reuse, evaluate, and here's the box that different. Make that component reusable. Now you're gonna say, okay, I'm gonna make it very, extremely tested, make sure it works very well, because the last thing you want your component, somebody else uses it and it blows up, right? So you add this extra piece here, which is make your component reusable, right? And then the rest is design, etc. So the only two changes is first look at how other people want to use this subroutine or this component, get a superset, and finally make sure you actually make it basically that component reusable. So that is kind of the nice way. So software development for reuse, often two separate development process. Development of a component and development of application using that component, right? So there's two parts to it. When you write a component for sharing, and also when you want to write an application that uses that component, sort of the producer and the consumer. When, when you write one that for sharing, you're the producer of that common component, but then somebody who's using it in their application is the second bullet point, is the user of that component. So there are specific forms here on that component-based software development, which I talked about it. We have software factories or software product lines, things like that one. That pretty much because you're going to mass produce these things and put it in these libraries. Okay. Now, these are some important terminology I want you to kind of remember, at least one or two of them. There's a lot of tools out there, okay, for reuse tools and techniques. For example, languages to describe composition. For example, most of you have heard of MEL or ADL or .NET. For example, module interconnection language or architecture description language, or some middleware like Corba or Java Beans or .NET. These are all actually reusable components, right? Because .NET is for everybody, Java Beans is for everybody, okay? So these are some of the key ones that we also use. What are some characteristics of good, successful reuse program? Extensive management support. That means, remember, if I write something for my own, it's kind of, think about it. If you're designing a bicycle for your own, that's your own bicycle, even if it's clunky and it's not that pretty, it's there. But if you want to make it for public use, you want to rent it out, you want to have other people use it, you need to spend a lot more. For example, a payment subroutine may take you half a day if you don't want to share it. But if you want to share it, it could take 2 weeks to do it, because you have to make sure it's perfect, good interface testing. So your management has to be on board with you. You cannot say, if your boss is going to put pressure on you to finish it fast, it's not going to be a good reusable one. But if your boss realizes it, or the manager realizes it, oh, this is a good reputation from now on, everybody's going to use this product. So they're going to give you more time and support you, basically. And also a lot of organizational support. Okay. There are some great organizations like Texas Instrument, like Microsoft. They do use a lot. Let's compare first. The Microsoft Office. Let's compare some of those products, like Excel versus Microsoft Word. See how much they reuse. Like a spell checker, they both use it. And, object drawing, when you draw a circle, formulas, editing, right? In Microsoft Office, you type in a letter, but in Excel, you also type it maybe in a cell for these things. So a lot of macros and all of those things are typically a lot of shared stuff. Also, you're gonna have incremental implementation. That's the best thing. Start adding things to things as opposed to have the big bang, right? If you want to have a good search routine or a good sort routine, start with numeric and then release it, and then add alphanumeric, then release it. It's pretty nicer because you could take care of all the features. Um, Unfortunately or fortunately, you need to have significant success and high incentives. Otherwise, managers say, why? Say, why do you want to share this with others? I want this thing for me. Okay. I want this for our project. So you need to have some high incentives, perhaps. It's kind of like a student in the class. Okay. I'll ask you to write a paper for the class, right? Maybe something on, blockchain. Okay. Which I'm going to give some people some projects like this. If it's only for our classroom, it's pretty quick. But if I say, hey, we want to use this for other universities, we want to post it on YouTube, it's going to bring honor to you, then you're going to spend a ton more time as opposed to a very quick and dirty one, because it's going to be on YouTube and permanently your name is going to be tied to it. So we need to have some high intense incentives, pretty much, that you got to get rewarded for making this more of a reuse component. And also, we have to do a lot of domain analysis. In other words, compare with other people. So if this is in the financial market, let's see how Schwab does it, how Fidelity does it, how Prudential does it. If it's in banking, let's see how Bank of America does it, how does Chase does it. If it's in gaming, let's see how Xbox does it or how Sony does it, and so forth, right? And also attention to a lot of architectural issues, because that's a very key thing here. Because what if you write a sort routine for a Java-based environment, but somebody else wants to use your sort routine for a C# environment? Okay, so you have to kind of keep these in mind. Perhaps it should be language independent. If it is component, maybe the binary is the best thing to share. Okay. What are some non-technical aspects of reuse? Okay, first of all, of course, economics. It is a long-term investment. Short-term, you spend a lot of time, okay, but long-term, you get a lot of benefits. Because think about it, right? Let's say you're writing a reuse for your own company, okay, maybe for for ExxonMobil or for Chase or for Intel or whatever. So if you write, say, a sort routine, you may spend 1 week right now if it is not for open source or if it's not for reuse. But if you make it a reuse, you have to spend 3 weeks. So you're actually losing 2 weeks, right? Immediately. Because if you do a quick and dirty one, it just takes you, let's go back, it takes you just 1 week. But your manager says, well, it's taking too long, but let's look at long term. But if from now on, you may have for the next 10 years, 50 projects, they're going to use your product. So instead of spending each one of them a week or two, they will spend just 1 hour, right? Because it's there already. They just have to link it in. Then it adds up. So in the short run, you lose, but in the long run, you gain a whole lot from that one, right? So management, it does not happen spontaneously. You have to let them know, okay? You spend time, you plant a seed, so in the future, other people in your company or other people in the field will take advantage. And of course, the psychology. People, this is one of the things I face a ton of problems with. It's called, people do not like to use other people's code. It's kind of like wearing somebody else's jacket, right? You like to write your own. You could say, wait a second, there are a million people write sort routines, but you want to write your own. Okay. So that is the psychology we have to get over. It says, hey, there is a component like this, there is a subroutine like this, let's use this one. But as I said, there are a lot of people who say, hey, you know what, I like to write everything from scratch. Okay. So this is what I call it the reuse devil's loop. This is sort of, the chicken or egg, or. So for example, why are you doing reuse? Because you want to have a lot of high return, right? So maybe the first project you spend more time to make a component reusable, but then the next one you reap the benefits. So to get high returns, what you need is many components, right? Of course, because if you have a lot of components, for example, Texas Instruments and Microsoft have millions of components that they reuse. So you need to have a lot of them. Small companies usually don't have a lot of reusable components. So for high returns, you need to have many components. But to have many components, you need a large investment. I mean, imagine if it's only one payment subroutine, maybe okay, instead of 1 week takes 3 weeks. Remember, the money is here, right? Because developers get paid a lot of money, right? I mean, you're gonna get paid $80,000 a year, so that's roughly about maybe $7,000 a month. So that means about $2,000 a week per one. So if three people working on this thing, it's gonna take $6,000. So instead of 1 week, if you do it in 3 weeks to make it reusable, that's 18,000. So you lose $12,000. But so it's a big investment, right? But if you think, well, down the road, I reap the benefits. So to have for this large investment, well, I need a lot of short-term gains. I mean, I need to have money to pay for these extra hours. So to have this, I need a lot of short-term gains. Well, short-term gain sort of inhibits or prevents you from large investment, which also prevents you from, many more components, which is from high return, right? So it's like real life, right? They say in order to make money, you have to spend money, but then you don't have money to spend. So what happens, right? I mean, the once they asked Warren Buffett, how do you make money? He said, you know what? You buy potatoes for $1, sell them for $2, and buy 1,000,000 pounds of them. Okay, but great, but I don't have $1,000,000 to buy 1,000,000 pounds of potatoes. Then what do I do, right? So this is the key thing. To make money, you have to spend money, but to spend money, you have to have the money. So this is sort of the devil's advocate that is so often. Remember, this actually applies to success in finance. If you have a good base, financial base, you could always build on it. But imagine if you don't. Let's say you have a lot of good ideas for stocks to buy, but you don't have money to buy them. Therefore, you never grew. But let's say you had some good money, or you were lucky to buy some good stocks. Now you started with $2,000, which is not much, but you made good bets and you bought good stuff. Now you have 100,000. Now this 100,000 you could buy a lot more, and therefore it becomes 1 million and 2 million. So it goes fast. But what if it doesn't? What if you only have $2,000 and you don't do anything with it, or maybe you invest and it's actually a failed investment? Your 2,000 goes to $500, and then you don't have it. So that's what I would say you need to have. This is sort of the devil's loop. So in summary, we can reuse different things. Okay, this is one of my multiple choice. Do we reuse code? This is a typical multiple choice. Do we use code, design plan, UML, or all of the above? Of course, the answer is all of the above. Then we talked about reuse can be systematic, which means software development for reuse. For is the good one, right? The one that you plan. Or opportunistic is called with reuse, right? Oh, accidentally I did a cool thing. Let's reuse this one. So the term opportunistic means with reuse. The term systematic means for reuse. Another exam question, please remember to tie these. So reuse doesn't just happen. Okay, as I said, it needs to be planned. You need to have a target in mind, especially for reuse, and your management has to be with you. Organization has to be with you. So we need to all have to sort of invest in this thing. So in the long run, we will go ahead and reap the benefits. As I mentioned, this is a very small chapter, sort of a quick summary of things. So we are done.